Hey there, I'm Travis, and I'm here from Alchemy Education. I'm here to teach you some chemistry. Today, it looks like we're going to be focusing on gases. Looking at the question as it's provided, it gives us an initial volume of oxygen as well as an initial pressure of oxygen. And it says that we're going to be putting it into this new container. In addition to putting it into this new container, it's asking what is the total pressure going to be when we add this new gas. That means that this is going to involve two different steps. The first part is going to involve finding the pressure of the oxygen. And in order to do that, we'll use the combined gas law. The second part then is finding the total pressure. And we'll find that using Dalton's law. So we're going to start with the combined gas law. Looking at the information provided, we have a pressure and a volume for our gas, and it's asking us for a new volume. Well, the combined gas law states that if we have a gas under one pressure, volume, and temperature set of conditions, and that if we were to modify that, we could find that that's equal to the pressure times the volume divided by the temperature under the second set of conditions. Now, technically, since we're only using pressure and volume, we would use Boyle's law. But instead of memorizing Boyle's law, Charles's law, or Gay-Lussac's law, it tends to be simpler just to go with the combined gas law and use one very simple fact about math. Math says that if it's the same on both sides, we can cross it off. In this situation, since temperature is not changing at all, that means then that we can go ahead and cross off temperature from both sides because it is held constant. That means that we would then find the pressure of the second container using the information provided. For the oxygen gas, the initial pressure of the oxygen gas is 1.0 atms, whereas the initial volume of that same gas was 1.0 liters. That was the container that it was in to begin with. On the other side, once we put it into this new container, we're not exactly sure what its pressure is yet. But what we do know is that its new volume is 3.0 liters. So that means then, using some algebra, we're just going to divide both sides by 3.0 liters. That allows us to isolate our variable, and it gets the unit from one side to the other. In addition, since liters are on top and bottom, they're going to cancel. That means that the pressure of the oxygen in this new container would be 1.0 times 1.0 and divided by 3.0. Keeping it to two significant figures, that would leave us with a partial pressure, or a pressure for the oxygen, of 0.33 atms. Now that we know what the pressure of the oxygen is going to be, we can now figure out what the pressure in the entire container is going to be. And in order to do so, we use Dalton's law. Dalton's law states that the pressure for a container is equal to the sum of the individual gases' pressures, and that each gas adds up to equal the total. Well, we know the pressure of the oxygen gas. We also now know, by looking at the information, the pressure of the gases inside the cylinder. And the pressures inside the cylinder is 1.00 atm. So in order to figure out the total pressure, we simply add them together. So the total pressure for the container then would be the pressure of the container originally, 1.00 atm, plus the new pressure that we just found out of 0.33 atms of the oxygen that we've added. Since we're adding the two numbers together, significant figures say that we keep the smallest number of decimal places. Since both values have two decimal places, we add them up to get a total pressure of 1.33 atms. I hope that this helps, and I look forward to answering your chemistry questions in the future.